Our third finalist will be Tian Nguyen. Hi.
Hi.
How are you?
Good, how are you?
Did I pronounce your name correctly that time?
You did.
Wonderful, thank you so very much. Tell me a little bit about what you will be sharing with us this evening.
So tonight I'm going to tell you a little bit about making bonds and breaking rules.
Tell me, do you break rules?
Never.
No. I guess we'll see after tonight's presentation. Everyone, let's give a round of applause for Tian Nguyen.
My name is Tian Nguyen. I studied organic chemistry, which is all about making bonds. Being an organic chemist is kind of like playing with Legos, just a really large set of Legos, where you're constantly figuring out different ways to put the pieces together. And the things that you end up making are really useful, from durable plastics to cleaner fuels to new drugs. And so that's where my research comes in. I help develop a method that connects a carbon atom to a nitrogen atom in a way that breaks one of the oldest rules in organic chemistry. It's called Markovnikov's rule, and here's what it says. When a carbon-carbon double bond reacts with an acid, this is just a molecule that's ready to give away one of its hydrogens. The double bond is going to take that hydrogen, and then nitrogen is going to add to the positive charges left behind. The nitrogen adds to the carbon with more groups attached to it because that's where the positive charge is most stabilized, and hydrogen doesn't count as a stabilizing group. You can think of it like bowling. So if you got 2 pins on one side and 1 on the other, nitrogen is the bowling ball, and you're always going to point the ball to the side with more pins. That's Markovnikov's rule. So as I've said, it's a very old rule. It's really quite powerful. In fact, you may even call it the Lord of the Rules. And so to destroy this rule, we have to go back to the literature. Specifically to an inscription from the Fellowship of the Rings, which I've done my own translation of. One rule to rule them all, one rule to find them, one rule to bring them all, and in the darkness bind them. So it's that last little bit that gives us a hint to how to break the rule. We found that by adding a molecule that is activated by light, so it's called a photocatalyst, you can take just 1 electron from the double bond and form a very special intermediate. It's called a radical cation. It has a positive charge on one end, an electron on the other, and they're constantly switching places back and forth. But ultimately, nitrogen adds to the carbon that has less groups on it, so that electron can stay on the more crowded and more stable carbon. And with that, we've just broken Markovnikov's rule. So to make drugs, chemists have to make and test thousands of compounds. With our method, we've given them 1 more tool to use and 1 less rule to worry about. Thank you.
Judges, what would you like to share with us about Tian's presentation?
Oh, well, thank you again. I thought at the beginning you did a very nice job introducing yourself, kind of showing people what you do all day. I think that's a question a lot of people have about scientists. What do they do? And the analogy about building with Legos I thought would work well, just to show people what you do kind of on a basic level all day, how you spend your time. So I thought you jumped a little bit quickly into just talking about atoms, and we all of a sudden saw the diagram there. I thought maybe, maybe if you had a little more time or a little bit more space to just say, some of the atoms that are inside you, there are carbon atoms, nitrogen atoms. They're also in drugs, things like that. Just maybe give a little bit more of a transition introduction to that instead of kind of jumping right into the diagrams. And I thought you did a nice job, actually, of keeping that on a level that would engage people, not getting too in-depth in actually what was going on. But maybe just a little bit of an introduction there, I think, would have been helpful.
Thank you.
Nice job. I loved your starting with the personal. I thought that that really brought us into you and wanted us to learn more about you and what you had to say. I also liked the analogy of the Legos. I thought that was very effective. And I felt, particularly in the beginning and part of the middle, you were really talking to the audience. You were really talking to people and allowing them into you. But I wanted to see you even go further with that. And I also agree with Sam about some of the transitions there needed to be more of a transition. You needed to lead us into building this suspense and then taking the time to land the next moment on us. Thank you.
Thank you.
I think that the entire presentation was really well done. Very nice pacing throughout. I don't know that I actually agree about the connection with the audience. I didn't feel as connected. I felt like you were giving a very well-rehearsed, very nice present. It was a great presentation, but I didn't feel as though it was really reaching out as much, even though within the presentation, all of the pop culture references to try and bring the audience in, I thought were just fabulously done. You know, Lord of the Rings, you're gonna get a geek's heart with that, right? So all of that was very well done, but I think there is still a little bit more work to be done there to really connect with the audience as opposed to continue to just talk to the audience. And then additionally, I thought that the topic, the difficult technicalities of the topic, I thought you did that very well, summarized it very nicely in an easy way. I do agree with Sam that a little bit of a transition there would have been a little bit more helpful, but I liked the way that you progressed through everything in your story.
Thank you very much.
Thank you.
Thanks, Kiki. You sounded a little bit like Simon there, but we'll let you pass on that. We'll let you pass, but this is not the American Idol. It's the ACS Chemistry Champions. Let's give it up for Tien. Before you leave, you join me.
Thank you.
I want to ask you,
Yes.
what do you think about the comments you received from our judges?
I thought they were great. I really agree, and in coming here this weekend, my slides have changed and my talk has gotten better, and especially working with these ladies, they really pushed us all to the next level, and we're really trying to get there, to connect with the audience and really walk people through the sciences. That's what we're all here for. So thank you very much.
Well, I know we've all done it, so let's give a big hooray for breaking the rules, everyone. Thank you, Tien.
Thank you.